Welcome. I'm glad that you're here. If you and I have not met yet, my name is Shannon Kiebler, and I am the moderator of our Math Expressions user group on Facebook and also the creator of the Math Genius Squad, which is a professional development service for math expression. So it's professional development, Google Slides, small group stuff, all the things you need to teach math expressions, no matter what grade you teach. So that's who I am. I'm so glad that you're here today. And we are addressing a problem. I'm going to call it a problem, a concern, something that I know a lot of teachers struggle with because it's something that comes up frequently when I'm in classrooms across the nations, whether I'm modeling lessons or I'm coaching or I'm just having some planning sessions with teachers. And this is something that comes up frequently. So tonight we are addressing how to get your students to be independent. And that's obviously a big conversation because for most of us, they aren't independent, meaning we start our lesson and students are with us. We think they're with us. We're guiding them through. It feels like they're getting it. We get enough formative assessment to be like, okay, I think they have it. We give them something like a quiz or a workbook page or a unit test. It does not matter. And all of a sudden, I have a line at my desk of all the students that don't know, that don't get it. Okay. Or I have all these hands fly up like, I don't know what to do. I don't know where to start. And I'm like, I swear that we were just there with me. We just did several problems like this. And now no one can work independently. So our job is to talk about how we can get students to be more independent. If you have that line at your desk, then you're in the right place. Say me in the chat. I want to hear from you. Okay, so tonight we're going to talk about these things. We're going to talk about how to use guiding questions. We're going to talk about an inquiry launch. We're going to talk about allowing for healthy, productive struggle and more catch and release. So I'm going to talk about all four of these. If there's one in particular that is of interest to you, please share that in the comments or the chat, wherever you're tuning in from, whether that's in our Facebook group or you're on our website right now there, or if you're watching on YouTube, we'd love to know which of these four is of the most interest to you. So let's first talk about questions. There are actually two different types of questions. There are funneling questions and there are focusing questions. And what I find is that we don't know the difference or we are generally stuck in one type of questioning or the other. Okay, so let's talk about funneling. Funneling questions are the ones that I find most teachers do. It is what comes the most natural to us. It seems the most obvious. It seems to get us from point A to point B the fastest. It moves us through our lesson the quickest, most efficiently, and it feels like kids are getting it. Well, I think that this is one of our issues. One of our issues in terms of why students are not independent is that we are doing too many funneling questions. So we know that this is an issue because funneling is guiding students down the teacher's path. Okay, so if you think about a funnel, right, we start up here with this big question, and then as we ask questions, we're limiting what students are able to say so that ultimately we get down here and we get the response that we want. It's very common. It's very natural. It leads to a desired conclusion. Like I keep asking the specific questions that are going to get me the type of answer that I'm looking for because that feels like what I'm supposed to be doing, right? They're almost always closed questions. And the teacher, not the student, is engaged in the cognitive thinking. So when we do funneling questions, these can all be major concerns or issues, right? So it mostly is because it's getting the undesired result, which is students are not independent. It leads to a desired conclusion. That's it. It's not responsive. So it's not based on what students are actually understanding or what they would intuitively do. Instead, it's almost like we're giving them the answer in our question. It's like when our face is like, so do you think that it's 7? And our head is doing this and kids are like, of course it is. I'm like, so you are going to do a 7, right? And they're like, nope. And I'm like, do you think that's the right answer? And my facial expressions, my heads, everything is giving it away. So they're just owning my idea. They're owning my confidence, but they have none on their own, which is why when I release them, they can't do it independently. So the other one that's really important here is that I want you to think about the questions that you're asking. Who's doing the harder work, you or them? And in funneling questions, it's generally you. You're doing and holding all of the cognitive load, and they're doing more closed answers. Yes, no, right, 13, 7, like one-word answers, things that aren't really expanding their thinking. They're just giving you the next answer that you're looking for. So now let's look at the comparison. I'm going to give you an example. Okay, the comparison here is focusing questions. So focusing questions are responsive to student thinking. I ask a question, whatever the student says, I'm trying to dig deeper into why did they say that and what do they think the next move is versus basically giving them the question or the answer that I want them to do. Again, we're going to give an example. It helps students make questions or connections. So if I'm doing the right type of focus questions, students are making connections, their own connections, and we know that connections are like 98% of teaching. When students make the right connections, they're able to function independently. And students are the ones that are involved in cognitive activity. Okay, so let's give an example. The teacher has posed this problem. Lena had 24 apples. She put them into 6 equal groups. How many apples are in each group? And the student Maya says, I think it's 4 because I know 6 times 4 is 24. Okay, now let's just say that Maya doesn't do that. We don't ask for an answer yet, okay? Instead, we have this, and the question that a funneling teacher might ask is, so are we going to multiply or are we going to divide? So how many groups are we going to draw? Let's talk about how many groups are in the picture or in the problem. Okay, how many are we going to put in each group, right? We think that we're helping. Those are closed question. There's 3 groups, or in this case, there's 6 groups. Okay, how many are we going to go into each one? And everyone's like 4 because 6 times 4 is 24, right? They're not thinking, why is it multiplication? Why is it division? What are the other ways we can represent it? Because you've asked the specific questions. Is it multiply or divide? So if anyone does addition subtraction, they must be wrong. But they're not even going to try that because you've only given them 2 options. You're going to say, what's the group number? What's the group size? You've already told them this is multiplication division. Just pick number pluck, friends. Just pull these numbers out. Those are funneling questions. The problem is that when they go independent, nobody's funneling. The question doesn't ask them those guiding questions step by step. The question is just the story problem, and students have to figure out what to do. But when they've never been really taught how to critically think because your questions are almost too helpful. Okay, we're being very helpful with the types of questions that we're asking. We're being really too helpful. So take a look here. Let's just say that's what Maya says. Okay, now if we're funneling, a funneling question would be like, okay, so what operation did you use? Like multiplication. Why did you use multiplication instead of division? Well, because I know it's equal groups. Okay, can you write that division? And they write the division in a sentence. And then what does the 6 mean? See, these are funneling. It's getting us down to, oh, okay, now I need you to understand that you can use multiplication to solve for division and that we can write it either as a division or a multiplication equation. Okay, it feels like, well, what's wrong with that? Well, compare it though to focusing. Okay, so now the teacher's trying to draw it out from the student instead of asking a question that really can only result in one answer. So you said 6 times 4 is 24. Where do you see those numbers in the story? Because let's be honest, there isn't a 4 in the story. There's a 6 in the story. There's a 24 in the story. There is no 4. So if I can dig deeper into where did she get that? Because most of the kids in the room are going to be like, wait a minute. How do I know that? Versus if I would start even drawing on the board, I'm like, oh, look, there's 6 groups, and I draw 6 groups, and then I put like 24 on the side, and I know I'm like doing equal shares drawing. I am basically telling them, this is how you solve, this is what you're going to do, and based on the drawing that I just did, now you can see where someone might get 6 times 4. But if I ask Maya, how did you get 6 times 4? Like, where's the 6? Where's the 4 in the drawing? How did you know that those were the numbers you're going to use? Whatever Maya says, I can make visual. That's good teaching strategy, because what her just yakking, okay, is going to lose half the class. Like, we have to make it visual. Or better, I say, Maya, how might you draw this story? Like, what does this look like? Because based on how she represents the problem, now we can ask better questions about where's the story in what she just drew. Can you retell me the story using your equation? So look at some of these other questions here. But the funneling versus the focusing is putting kids, the difference between who's carrying the cognitive load and who's able to talk themselves through some of these questions when we have to make them independent. It's harder than it seems, but that's one of the issues that I'm seeing. The other issue that I'm seeing as to why students cannot be independent is we are lacking this inquiry piece of our lesson. We are addicted, obsessed with guided practice, but almost to an extreme, like the I do, we do, you do. We seem to be somewhat obsessed with it. Okay, so we say, I do. Students, today I'm going to teach you how to do equal groups of multiplication, and all of our story problems are going to be multiplication story problems. Well, now you just blew. Why are you not surprised they're just taking numbers and plucking them and doing multiplication? They couldn't tell if it was about apples or if it was about bicycles. Like, they don't care because this is about number plucking. That's a problem. That means when they get on their own and they read mixed up story problems or they read any story problems, they freeze because no one's there to break down the problem for them. No one's there to tell them what operation to use. No one's there forcing them to go a certain direction with these problems. Now they have to figure it out and they're not used to it. Okay, so that I do, we do, you do is almost too much. Like I'm going to show you what to do, then I'm going to guide you what to do, then I'm going to release you. It's good in theory, but I want you to see how maybe we can start to change it or alter it just a bit. Okay, Expressions was actually built on an inquiry class model. Okay, so it was funded by the National Science Foundation, which means I want you to think about it more like science, less like reading. Okay, and it doesn't mean I'm going to stay in inquiry for a whole lesson. Okay, there are some very extreme programs that do that. That's not expressions. It is just a short time. So when you go to introduce a topic or a lesson, instead, I want you for 5 at the most 10 minutes. You start with a question that is not closed. It is open. Remember, a closed question is yes, no, thanks, 16 square, parallelogram. Okay, there's like one answer they can get. An open question would be, and show me multiple ways, or how do you know it's a square? Like there's something there that there would be multiple ways that students could get around it. And I ask the question and I say, what do you think you would do? I want to show me at least 2 ways. Anytime I do an inquiry launch, I almost always say, and at least show me 2 ways. It could be a notice and wonder. What do you notice? What do you wonder? And I show them an image. I show them a place value chart. I show them, right, whatever. It might be I'm in kindergarten and I say, we're supposed to be building team numbers today. And I want you to go back to your seats and I want you to show me the number 13 at least 2 ways. And I don't model for them. I don't tell them how to do it. I don't give them an example. None of that. I just say there's tools at your seat. You might use the blocks. You might use the base 10 blocks. You might use the 10 frame. You might use the number tiles. Up to you, friends. But I want you to show me 2 ways you think we can make the number 13. Okay, now I could do a double-digit equation for 2nd grade. The first day we're doing regrouping, ungrouping, whatever, right? So your job is, what do you think we might do here? How might you start this? In 4th and 5th grade, I'm doing decimals, and I might say, I might write the word 1/10 in words. And I just say, what are 3 different ways you can show me what these words mean? Because I'm looking to see who might draw a fraction, who might draw a picture, who might write a decimal, who already is coming to the table with some other information. So the 5-minute to 10-minute piece it's flexible because the only reason I'm doing this is I need students to trust their intuition and they don't trust themselves, which is why their hand is up every single time you ask them to be independent. I don't get it. I don't know. That one kid you're attached to the hip to, right? Like you cannot leave their side because if you leave their side, they cannot function at all. It's because they have learned helplessness. They have learned when I don't know, my teacher is uber helpful. They will point to it. They will draw it for me. They will tell me step by step what to do. I don't have to own this learning at all. Instead, in an inquiry launch, I'm like, I'm actually not helping and we're not moving on until everybody tries at least 2 different ways to answer this question. And what you're doing is you're reframing math for them. You're saying, this isn't actually about being right. In fact, I'm going to tell you right out of the gate, I don't even know that you have all of the tools you need to solve this. I just want to think, what would you, if you did know, what would you do? Okay. So I know you feel stuck, but what would you do? And then students all of a sudden they start and like, maybe you draw a picture, maybe use some numbers. And I'm walking around the room and I'm like, oh, I love it. Rachel decided to start drawing a picture. Her picture is so wrong. It's not even close. It does not matter. She's trying something. Everyone else like, oh, Rachel's drawing a picture. Maybe I should draw a picture. Okay, I just need kids to start to think, maybe I do have something in here, in me, that can get started. Now, there's a difference between going from productive struggle to unproductive struggle. We don't want the shutdown. We don't want the head banging against the desk. We don't want them to get in incorrect thinking and they now solidify ideas that they think will work and they don't work, okay? So generally for me, when I do inquiry, I don't let students finish the problem. I just let students get started because kids oftentimes won't start because they think they have to be finished. And if I don't know that I can do it all correctly and all get it right and get to the end, then it's easier for me to just not start. So if I send the message, I don't actually expect you to finish. I just need you to get started. Now, for some of your students, who are a lot of times are overachievers, they will panic because they do not like not finishing. And that makes them very uncomfortable. And I need them to sit in that comfortability because that's what math really is. Math is not solvable instantly, all the time, immediately. Oftentimes takes several revisions. It takes several options, tries, days, and they need to sit in that. So I say, here's the problem. What do you think you might do? Go try it. I'm walking around the room and I'm doing it enough to get what types of ideas are out there. And I'm gathering the ideas that are going to help me to teach it explicitly using their ideas. So let's go to the kindergarten example of the 13. I'm using a kid who did it with counters. Okay, and he just did 1, 2, and he literally counted by 13 by ones. Okay, that is the most concrete version of this. I'm going to take that idea. I get someone else who puts them in a 10 frame, and he has a group of 10 and 3 extra. That's even better. I really need kinders to get to a group of 10 and extra. I'm going to get someone who did a 1 tile and a 3 tile because they think that looks like 13. I also have someone who did a 10 tile and a 3 tile. That's more clear. That's better. I'm looking for, what does the teacher's guide say is the point of this lesson? What are the methods they want me to teach? And whose work looks the closest to that, where I can use their work to teach these ideas explicitly. Okay, so the 5 to 10 minutes, 10 minutes is probably kind of extreme. It's really more 5 of just getting started. And when I get enough, I'm like, okay, I see where people are going. Everyone got self-started. I'm like, everyone stop, meet me back at the carpet. Okay, we come back to the carpet, they leave their boards because I'm going to gather their ideas and bring them anonymously to the front. And we're going to talk about, okay, so where do we start here, friends? I love this. And I bring it up. I love this person. I can tell they didn't finish. I'm going to tell you, this also doesn't solve it. But you know what I love? That they got started. Let's look at this one. Okay, I start with the least of what I wanted and I grow it to what I want the most. And by the time I get to the most, I'm saying, so friends, I love all the different ideas we had out there. What we just discovered is that we can build the number today with a group of 10 and extras. And we can build it with a number tile 10 and a number tile of 3, and those both mean 13. Friends, I love all the other ideas that are out there. Some of us tried some things that didn't work. Would you turn and talk to your neighbor about something you tried that you're like, oh, wait a minute, I want to change my mind. Let students change their minds and be okay with the fact that they did it wrong, versus some of us like, we can't talk about that. They're going to be sad. They're going to cry. They're going to be ashamed and embarrassed. I'm like, it's only because you've made not being right the first time embarrassing because you don't ever talk about it. Okay, so in this case, I say those things and then I say, now go revise your thinking. Would you all go try Trey's way? Remember Trey, how he built it with a group of 10 and 3 extras? Your turn. Okay, did you see how John multiplied the whole number times the denominator and he added in the numerator? I want you to go use John's. I'm going to anchor it. Here's how it worked. I teach it explicitly. This is what we're doing today. This is the model and how we do it. This is what I'm looking for. You have 3 different options here. Go choose, and I might just say, go use John's, go use Trey's, go revise your thinking. What would you do now to change your work? The only thing I did different there is I made them start, and then I made it okay to not know and to go back and revise. Do you see how that might help them to be more independent? Because now when they get to something they've never seen before, it's not, I don't know, I've never done. They are used to this idea of like, okay, well, what have I done before when I didn't know? Why she was okay with I drew a picture. Maybe I should just draw a picture. Or I wonder if I should try Trey's way like last time. They're like thinking, what's the next step? Because it's not like, well, I'm just going to wait till the teacher tells me, because every day she walks in, she tells me what to do, and I just wait for her to tell me what to do. And if she doesn't tell me what to do, I don't know what to do. And now they're not independent. Okay, so I want you to think about your focusing and your funneling questions. I want you to think about the inquiry launch. I want you to use student work. You highlight important ideas, and then you try the problem, a different problem using one of those ideas, and you say, everyone go try it. But more importantly, you first send them back to revise the first problem. You don't always need a new problem. They didn't get the first problem the first time. Why are you giving them a new problem? Just say, everyone go back and revise your thinking. How would you change your thinking now to look more like maybe what an idea that Trey gave us or Rachel gave us? I love what we learned from Sarah. Remember, Sarah showed us we could count by ones. Sarah, genius. What a good idea to start. Sarah, what might you do different? And Sarah's like, I think now I'm going to put them in a group of 10. I'm like, right, I'm not saying you were like what you did was bad or wrong. I'm saying I liked what you started, and here's how I'm going to grow it. Now go try this next person's idea. So if I go from inquiry launch, it's important that you find that balance between the healthy and productive struggle. Okay, they have to like try some things on, which is why the math expressions whiteboards are so important to this. Okay, math expressions whiteboards, first, they have so many scaffolds on them. So many. I know they're annoying. I know they're flimsy. I know they don't fit in desks. There's a lot of things that are annoying, but the tool is very powerful. And if you're like, my kids don't have number sense, they don't know their math facts, I'm like, then why aren't they using their math board? Their math board have all the scaffolds built into it. Okay, so that's one. Second, though, is what we find is that when kids use whiteboards, they're more willing to try to erase and to try again and to revise thinking. When they are only in a workbook, they think it has to be perfect and right the final draft the first time. So I encourage you to include that whiteboard, and that's going to be a part of that healthy, productive struggle. Now, I'm also going to use their community. And I'm going to say, if you are totally stuck, I don't want you to get to unproductive struggle where now we're having meltdowns. Hey, if you don't know, look around, stand up, do a gallery walk, go walk around. What is everyone else doing? I am literally giving you permission to cheat because it's not cheating in my classroom. That's called community. When I don't know what to do, I ask somebody. I look to see what they're doing. Adults, you do it too. At a table, I give you a fraction question. Everyone's like, your eyes start wandering, like, am I doing this right? All of us, we're unsure. We want affirmation that we're on the right track. My only thing is, if you take someone else's idea, you have to explain it. So if you like what Rachel's is doing, go use it. It's going to help you get started. That's better than the line at my desk where I'm the only one that help you get to the next step. And then if you use Rachel's idea, ask her how she did it and make sure when I ask you, you know how to explain it. Great, use her idea. Okay, I know we have some comments. I'm going to get to them here in a minute. So my friends, I want you to think about the last one, which is catch and release. I want you to do catch and release more often. So for some of us, we're holding their hands the whole lesson. We are guiding everything. Others of us are doing too much independent practice. We release them to go do the whole page. That's too much. Okay, so when I say catch and release, it means I like the inquiry, like I pop it out. I say, how is everyone doing? I get enough ideas where I get like where we're going with this, where I need to go next. I quickly pull them. I'm catching them. I bring them to the front. We make some mathematical points. I release them. Go try again. I'm doing some guiding questions, okay, focusing questions. And then I'm like, okay, let's try another one. I throw out another problem. Remember, we're going to use Trey's way. Remember, we're going to do X, Y, Z. We might discuss an error. Friends, go back to your seat. Try it again. So I catch them. I make an explicit point. I remind them of something. I release them. They go try it. Okay. After I've done that, now I say, okay, now friends, it feels like, 5, 4, 3, 2, 1, a formative assessment. I get the sense that like we're starting to get it. I might say, I want you to do the next 2 problems now in your workbook. I don't say go do the whole page. Okay. Go do the next 2 so I can catch and I can sense the common errors. We can discuss. I'm going to release you for even more. I might even release a subset of you. Okay, this group of people, I'm going to release you next to the next 5. But there's always a protocol. It's never just like go finish it. Because the go finish it means I don't really care about your thinking. I really care about the final product, which is just answers. They're not talking about the math. They're not modeling the math. They're not drawing the math. They too think this is about completion. So I got to ward that part off. For the kids, it won't work without me. I want them to be independent. So even the small group, if I pull them to a back table, I will say to them, here's your next problem. Your job by the time I get back is to have a drawing that you think will work and let's say a numeric method that you've started. That's your only job. Or by the time I get back, you need to have built it with secret code cards and have the fraction manipulatives that match, whatever the topic is. Okay. I literally stand up and I leave the group for about a minute and I go check on what everyone else is doing as I'm releasing them. And I come back. Because if I sit with that small group, I am creating helplessness step by step every time. They will never be able to do it on their own. But I'm saying to them, no, I'm not doing this for you. And I'm not even modeling it for you. You get started. We've already done some models together. Okay. If I have to model explicitly, some kids need that. Of course I will do it, but I still release them now. Next problem. I just modeled this. Next one's on you. I'm standing up. I'm leaving. I'm going to come back. Let's see. Okay. Everyone has this. I'm going to modify. I'm going to correct. Okay. Let's try again. Next step. I'm going to leave. You have to do it. Right. And I'm going to ask the questions of what do you think you should do next? I'm like, I don't know. I'm like, if you did know, what would you do? Like, draw a picture. Hey, that sounds like a good idea. Don't squelch their intuition. Try it. Like, I think that I'd multiply. They shouldn't multiply. Try it. They will only ever start to trust themselves if they learn that they can try and fail. So I'm like, they tried multiplication and then whatever happens, obviously it doesn't work. I'm like, so did that work? Your answer got bigger. And in the story problem, we said, that some of the things went away. So did multiplication work? And they're like, no. And I'm like, but I love that you tried something. So now multiplication doesn't work. What would you try next? Like, well, maybe I think that means that it might either be division or subtraction. I'm like, oh, that's an interesting idea. Why don't you try that? Notice my response stays the same no matter what. But whatever they say, I don't say, no, I don't think that's going to work. That's funneling. Are you sure? What are they supposed to say? No, yes, like, of course, right? No, okay. Why do you think that? Well, because try it. And when they try it and it doesn't work, they actually are going to remember why it doesn't work versus you say, don't do that. Everyone always does that mistake. Don't do that. That doesn't work. And then they just follow the leader because every time you tell them what works. Okay. So Keep thinking about this. And I want you to think about, am I part of the reason why my students are not independent? I'm fostering helplessness. It has to do with our questioning. It has to do with our catch and release. And it has to do with how we're launching new topics. Are we fostering intuition? Are we fostering, you don't know, you need me to know? I'm like, no, you don't need me. You know how to do this. Get started. I will help you once you get started. I will help ask the right questions that make you think about what our next move might be. If you are in the Math Genius Squad, remember, I'm helping you with this. In your slides, I want you to look for this. So in your lesson, I've put this rocket, and I'm going back through all the lesson slide decks, and we're adding them to everything, okay? Because it's not clear in the teacher's guide when to do that inquiry launch, and I want you to know I've purposely built it in. I said, when you start this lesson, you're going to start here, and I want you to launch it with inquiry. This is the do not tell them, do not teach it. See what they'll do first, and then teach the next explicitly, then catch and release as you go through the lesson. Okay, so don't forget, you go to your stage 2, you click on lesson materials, you open up your slide deck for that day. If it's a day where we're not just building fluency and it's inquiry based, I'm going to give you a clue that it's inquiry based. All right, friends, post your questions and I'm going to look to see what we have. I know we have some things listed here. So in order to get to the focusing questions, the teacher would have to funnel first if the students don't know how to enter the question. It's possible, right? So there is a blend of focusing versus funneling questions, but the difference is that funneling gets us to a specific types of questions versus, why did you try that? What do you think? Now, I might throw in some funneling questions. That's just natural, but I would more challenge you to just see, like, am I asking all funneling questions? Like, am I getting the answers I want during the entire lesson? And they're always kind of the answers I want because I must be funneling. Like, if you're always getting the right answer, you're not asking the right question, right? Because we know that they don't actually know those things. They're just being heavily led to get those answers. So I have to ask better questions. So would I say that the types of tasks used influence the process of questioning? I would say that. Okay. So would the types of tasks used influence the process of questioning? Yes, which it goes to the inquiry question. If you ask the right type of question, you're going to get a better selection of responses. So if that's closed versus open, right? And then that's kind of what I do in the Math Genius Squad is I help open the question up a little bit more. The questions come from the expressions. I'm just helping you pull the right ones out. I often start with Puzzle Penguin. There's some other things I do to help make sure it's more engaging. And of course, this is based on a growth mindset classroom. So what else is on your mind? What else can I help you with? What other questions do you have? Post them in the comments. I'd love to hear from you. I'd love to know what strategies you try and what things you heard that are a win-win for you. All right, my friends, thanks so much for joining us. Happy Math Crush Wednesday, and we'll see you next time. Bye for now.